Hey, hello there, and welcome back to another Advent of Code video. So today is the 5th day of Advent of Code, and so far we have been keeping up with this. So let's keep going. Let's look at the Advent calendar. So it seems, I think we are following this trail of stars, and we are now in this island, floating island that has like islands inside of it. So let's see what it is about. Day 5. If you give a seed a fertilizer. Well, I'm sure that this is a reference to something which I'm sadly not getting. But, well, let's see what... Oh, this is a pretty long... pretty long problem description. So, you take the boat and find the gardener right where you were told he would be, making a giant garden that looks more to you like a farm. Managing a giant garden that looks to you more like a farm. Okay, so it's not really a garden, it's a farm. A water source. Island is the water source. You point out that Snow Island isn't receiving any water. Oh, we had to stop the water because we ran out of sand to filter it with. So what is this? A sand filter. Okay. I didn't know that sand was used to filter water. Can't make no snow with dirty water. Don't worry, I'm sure we'll get more sun soon. We only turn off the water a few days, weeks. Oh no. His face sinks into a look of horrified realization. Wow, this turned pretty dark. I've been so busy making sure everyone here has food that I completely forgot to check why we stopped getting more sand. There's a ferry leaving soon that is headed over to in that direction. It's much faster than your boat. Could you please go check it out? You barely have time to agree to this request when he brings up another. While you wait for the ferry, maybe you can help us with our food production problem. The latest Island Almanac just arrived and we are having trouble making sense of it. Almanac? Is this the same as almanaque in Spanish? Kind of, but not quite. We called almanaque basically a calendar. Okay, the almanac, your puzzle input, lists all of the seeds that need to be planted. It also lists what type of soil to use with each kind of seed, what type of fertilizer to use with each kind of soil, what type of water to use with each kind of fertilizer, and so on. Every type of seed, soil, fertilizer, and so on is identified with a number, but numbers are used by each category. That is, soil 1, 2, 3 and fertilizer 1, 2, 3 aren't necessarily related to each other. Okay. For example, seeds, these things, seed to soil map, soil to fertilizer map, fertilizer to water map, and so on. Okay, and these numbers, are these the same numbers? Okay, so I don't know what's going on here. Seeds are some numbers, but I don't see these numbers repeated. Okay, let's keep reading. The almanac starts by listing which seeds need to be planted. Seeds 79, 14, 55, and 13. The rest of the almanac contains a list of maps which describe how to convert numbers from a source category into numbers into a destination category. Okay. So I guess like seed to soil map has maps that tell you how to convert seeds to soil numbers. That is, the section that starts with seed to soil map describes how to... Okay, yeah, exactly what I said. A seed number, the source, to a soil number, the destination. This lets the gardener and his team know which soil to use with each seeds, which water to use with with which fertilizer, and so on. Rather than list every source number and its corresponding destination number one by one, the maps describe entire ranges of numbers that can be converted. Okay. Each line within a map contains three numbers: the destination range start, the source range end, and the range length. Alright, consider again the example seed to soil map. So this is the seed to soil map. The first line has a destination range start of 50. A source range, it's weird that the destination is first and then the source is second. I would have thought that seed to soil would have like seed and soil, but this is destination, soil, and source, seed. And a range length of 2. Okay, this line means that the source range starts at 98 and contains two values, 98 and 99. The destination range is the same length, but it starts at 50, so its two values are 50 and 51. With this information, you know seed number 98 corresponds to soil number 50. Okay, so you start with seeds, and with this you can go to soil numbers, and that seed number 99 corresponds to soil number 51. Okay, so it's a mapping, and that describes this first line. The second line means that the source range starts at 50 and contains 48 values, 50, 51, and so on until 97. This corresponds to a destination range starting at 52, okay, weird that they are so close, and also containing 48 values, 52 up to 99. So seed number 53 corresponds to soil number 55. Okay, I guess that math checks out. I trust this. So yeah, 53, this is the source, so it's 3 more. The destination, yeah, it's 55, so 3 more than this. Okay, yeah, makes sense. Any source number that aren't mapped correspond to the same destination number. Okay, so seed number 10 corresponds to soil number 10. All right, so the entire list of seed numbers and their corresponding soil numbers look like this. So 0 maps to 0, 1 maps to 1, and so on until 49, and then 50, which is on this map, and yeah, source 50 starts mapping like 2 more, 52, 51 to 53, and so on. Yeah, until 97 and 99, but then 98 maps to 50. And okay, 99 maps to 50 to 51, and 50 and 51 are exactly between, like sandwiched between this 49 and 52, I guess. Okay, I hope that the ranges, like the source ranges, don't overlap. I guess. With this map, you can look up the soil number required for each initial seed number. Seed number 69 corresponds to soil number 81. 14 corresponds to 14, 55 to 57, and 13 to 13. Okay. The gardener and his team want to get started as soon as possible, so they like to know the closest location that needs a seed. Using these maps, find the lowest location number that corresponds to any of the initial seeds. To do this, you'll need to convert each seed number through other categories until you can find its corresponding location number. So location number is what? The last thing on here? Yeah, humidity to location map. Okay, so the last kind of type of thing is location. And you start with all of the initial seeds, map them through, get their locations. In this example, their corresponding types are seed 79, soil 81, fertilizer 81, water 81, light, okay, and so on until you get location 82. So okay, for each of the 4 initial seeds, you get 4 final locations. So the lowest location number in this example is 35. What is the lowest location number that corresponds to any of the initial seed numbers? Okay, and the puzzle input is, okay, many more seeds with giant numbers, and maps have many more ranges, also with pretty big numbers. Yeah, I guess they need to use pretty big numbers so you don't have to you cannot binary search the answer. And these numbers are pretty big. Yeah. Also the ranges are pretty big, so you cannot expand these ranges into look at this. This is 700 million range long, so you cannot expand this into, I don't know, have a hash map of 700 million and with all of these things, because it will explode your memory. So of course you have to be sort of intelligent there. But okay, this was a very lengthy description of the problem, but I think that the problem itself is not so complicated, I think. So you have to start with these numbers and basically map each of the seed number into a location number, going through all of these sort of maps. Yeah, and each map has a set of ranges that map one number to the next. They are also in order, so we start with the seeds and then have seed to soil, soil to fertilizer, fertilizer to water, water to light, light to temperature, temperature to humidity, and humidity to location. So the titles of the resources, I think, are not even important. We can just go in this order. Yeah, so let's go into the code. So jump into this and open the code. Yeah, and by the way, yesterday I introduced a little bit of anti-boilerplate code. So we have now our template is a bit simpler because I introduced this couple of a type for our dynamic error result and a little function that does the whole reading of standard input. So we don't need to import anything in the template and just do AOC result, that is a dynamic error result. We don't have to type din error everywhere, and just do AOC read std in to read all lines of standard input. So we copy the template as usual. The name of this thing was if you give a seed a fertilizer. And I would like to know what references, what that is a reference to. So if you give a seed a fertilizer, okay, and let's also copy the inputs. So this is day 5. Let's copy the real input into input.txt. Let's also copy the sample that we got, this thing, into sample.txt, and into sample out we are going to put the answer, the first answer that we want, which is 35. Okay, so now let's go to the source code, close everything else, and think a little bit. So we have, let's also check the sample. So I'm thinking about whether to, like, how to model this thing, and I think I want to avoid like over modeling this for part 1, because we still don't know what part 2 is about, and sometimes part 2 changes a lot of the assumptions that we made. So I don't know if we need to like model you know, like a struct, I don't know how to call this thing, resource, and have like you know, I don't know, seed is the first resource that has a number, and then you would have fertilizer or whatever comes next that has a number, and so on. Now this would be an enum. To model this like this, I think it doesn't make sense. Also, we need to be like generic on the type of resource that we like sift through in this chain. So I think I'm not going to model this, but I am interested in model this these ranges, because they have some interesting logic, and just using a tuple of 3 values that are in a weird order to what I would think, because this is seed to soil number, but this is the source, so these are the seeds, and this is the soil number that it corresponds to. So I think I want to at least model those little things. So yeah, the ranges. So let's call this thing a range, or yeah, range map, and we'll have destination range start, so source range start, and length. So destination start, let's say, is this. I guess U32, like the real input actually has very big numbers. Yeah, like 2 billion. So I guess this is like 3 billion here. Yeah, they seem to be in the range of 32 bits, which is like 4 billion. But we can make it then 64 bits if need be. And I think running in debug mode will catch any overflows or anything, so we should be safe there. Source start, let's actually have them in the order that I want. Source, destination, and length. I guess I could call it len as Rust likes, but why be? Yeah, let's use actually correct words instead of too short things. So yeah, this is a range map. Don't need to say like source range starts, because we are already in a range type. So let's do some parsing, I guess. I want to, what do I want to have? Well, the initial seed numbers, that's for sure. Then I'm going to have like each of these maps. I guess I could also have a struct for that and say that a map is like a vector of these range map things. Yeah, but I could also just say this. Map is a vector of range map. That's it. And let's get parsing, I guess. So yeah, I will just get a list of maps or a vector of maps in the order that they come here. And that's it, that is all the information that I want. So how do we do this? Let's extract, let's say, let seeds and maps be parse input, and just pass the input. And think about this, generate this function. I mean generate this function, not generate this function. So this should take actually a string slice. Oops. And it will return the seeds, which will be just a vector of numbers. And the maps which will be a vector of maps. And the type definitions are already paying off. So how do we get the seeds? Well, we can first split the input by double new line. So let's say what do I want to say? Sorry, I got a bit of mental block there. Hopefully Mate will make my mind work. So, oh, by the way, this is probably going to need to be an IOC result of these things. And here we are going to propagate any error up. So let's split at double new line. So this will be our seeds part and rest. You don't like this because what? Why are you using? Oh no, I meant to use split once. My bad. And the result that we want, well, let's wait for that. Okay, we have this seeds part and the rest of the things. And then let's have let seeds be seeds part strip prefix, and we have the text seeds. We're gonna strip that away, and then we want to do what? Split by white space, I guess. Yeah, or we can just use space here and map each of these to stir parse, like to parse these numbers. Since I'm going to be parsing numbers a few times, maybe I could extract this function, but for now let's inline it. And then I want to try collect this and early return. So, do you like this? Probably not, because strip prefix returns an option instead of a result. So let's say, okay, or, and invalid input. My error messages are not very nice today, but this does compile at least. And in the end, we're going to return OK with seeds and with maps, which maps we haven't defined yet. And let's break this long statement into parts. So this is, let's call this seeds. Like this is just the text with the seeds in them, and then we parse the seeds number. For now, let's print the seeds. My cat is playing with the door there. And the maps, we still don't have them, but we can just print them. No input length. And for the maps, let's just return an empty vector for now. Okay. So, what are you complaining about here? Oh yes, we need to... Well, you know what? Let's not print the maps. Or, I mean, I will want to print them once I have that idea. So let's derive debug once I have that implementation, just to check that I'm doing things right. So let's cargo run this day 5. If you give a seed a fertilizer with the sample, and yes, we have the seed numbers. That seems fine. Now let's think about parsing the maps. So these were the seeds, fine. Let's now say for the maps, what are we going to do? Let maps be rest, and we're gonna split again by double new line, but this time we have a lot of them. And for each of those, what are we going to do? Well, let's say map with a function parse map. Let's do a trick here. We have a block, and we're gonna say parse map block, which we'll try collect, and here we return the maps. Okay, this parse map doesn't exist, but let it generate this function. So I used the closure here instead of saying parse map, so that Rust Analyzer knows a little bit of what I want. So okay, we have the block. Block would be like one of these things, these parts, and this should give us an AOC result. Okay, and now Clippy, because I integrated Clippy with VS Code, is telling us that there is a redundant closure here, and maybe it can replace it. Yeah, very nice. So how do we parse one of these blocks? Well, we will get I guess here we need to get each line, so maybe we can do block lines. The first line is the map title, which I don't care about, I think. So we'll do drop 1. Is drop a function here? Dropping skip. I think it's skip what I want. Skip the first line and then map each line and let's say this range map parse the line, and then we are going to try collect, or is it collect what I want? I think I can just say collect here, and it should infer the proper type. Generate parse function, please. So yes, this inferred the correct type. That's awesome, but it doesn't use the type alias, but that's fine. And again, Clippy says that this can be replaced, so that's a nice delegation here. And we are now parsing a single range, so this should be easy. I think we can say line, basically the same logic that we have here, basically. So line split by space, and then these things don't have like double spaces or things like that, right? Yeah, no, they are not trying to like do a columnar, how do you call these things? Like align the numbers on each column. Let's also check the input. Yeah, they are not aligned. That's nice. So a single space will suffice. And we try collect. Okay, this will give us numbers basically. So let's say let nums be this, and numbers is gonna be a vector of numbers. Fine. And then we want to say something like, well, we want to receive 3 numbers. So if we have and the order of this was destination range first, so destination start, then source start, and then length is gonna be the nums. Is this what I want? Or else, if they aren't three numbers, we'll early return an error, I think. So we can say error with expected 3 numbers for a range or something like that. And then finally we'll return a range map with source start, destination start, and length. Is this okay? Well, this should be an okay source map of this. Okay, this seems to have worked. Does this make sense to do? I think kind of does. I think this is the same as saying, instead of using this let else, as saying like try into, and try into, what does it? It does already give you a result. So you can also say this, and yeah, it's a bit shorter. I think that's fine. We could convert, say here, okay, or, well, if this is a result, is map error what I want, or map or? I'm not exactly sure what I want, but maybe the try into is fine for this. We want to propagate errors up. And here I think I want to do a pretty print of the maps. So let's run this, and we got something. So is this correct? So the sample says for the first map, the length is 2, that's fine. Source start is 98, yes, and destination is 50. That seems fine. Okay, so we did the parsing, it seems. And well, it did took some time, but it's done. What to do next? Well, we need to do this conversion from seed up to location. So how do we do that? Let's think a little bit. I feel a bit somewhat foggy today, but this doesn't seem too difficult. So let's give it a try, and if I get blocked, maybe I will take a rest. So we have to go, basically we are going to map each seed, right? Let's say we want to say seeds map to something, like to the final location number, dog is barking, and then get the minimum out of this, like the least, what is the lowest location? Yes, so whoops, I'm gonna say min, I don't remember if, oh, we need to iterate, so iterate each seed and get the minimum, and this will be let min location, and we're just going to print that. Okay. And you don't like this because it doesn't implement what? Why do you know what? Why do you think that this will be an option? What are seeds? We do have the correct types here. Oh, because minimum can is optional, because maybe we have no seeds. That is true. Like an adversarial input would have no seeds. True. And you know what? If there are no seeds, I will just say 0. So do we have a min? We don't have a min or, but we can do, of course, or here. We want map or blah blah. I think what I want is just simply unwrap or. We're gonna say unwrap or 0. Okay, so now we are going to map each seed to what? Well, we have to go through each map now. So how are we going to do that? What I think what I want to do is let's say let mute number. We're gonna start a number with our seed, and then we're going to go through each map and ask, like, please map this number. And then once we are done with all the maps, that's it. We're going to have the location, I think. So for each map in maps iterator, yeah, I think we are just simply going to say number, and we can say this map number, passing the number and the map, and return the mapped number, the final thing. So please give me this function, and this I guess could be also what we call a map. Let's take this thing down. How do we map a number? Well, each map again has ranges, so we have to see if the initial number falls within each range source range, and if it does, map it to the destination range, and if no source maps anything, like matches the initial number, then we will fall back to the same number that we got. So yeah, that should you don't like this because where are you expecting what? Oh, this is a reference, okay. Well, let's not use a reference, I guess. Okay, so how do we do this? I think we can use a simple for loop. So for each range in the map, so range here, I guess is going to be, yeah, reference to range. We can say what? Well, we can delegate to the range to map the single number, and maybe that operation can fail if the number doesn't fall within the range source. So let's say if let some mapped number be range map this number. So if we can map the number, then we're going to early return the mapped number. Otherwise we keep going. And finally, if we couldn't map anything, we're just going to return the same number that we got. Okay, and these, maybe we can call it like try map, because it can be like, it's an optional thing. And let's generate this method. I really like to program in this like delegating style. And now for like the final meat and potatoes of this thing, we gotta check if the number is within the source range. So if the number is greater or equal to self source start. I think I can also ask this with ranges, like using actually ranges like source start up to source start plus length or something like that. But let's just use the numbers here. So what do we want? Yeah, the number to be within this. So let's write it in like actually like a sandwich of things. So if this and number less than or less than self source start plus self length, is this correct? So if the length is, for example, 1, yeah, source start plus 1, we want to be less than that, so it would be a range of only 1. I think this is correct. If that's the case, then we are going to return self. What do we want to return? Basically the number minus the self source start. We know that the number is equal or greater, so this is not going to underflow. And what? We need to then add the destination start and say, hey, sum, right? Yeah, I think so. And otherwise, we'll say none. I think so. I think this is correct. Not entirely sure. This plus destination start, is it correct? So let's follow one of the examples. We had 79, which falls in this range. So we subtract the source start, we subtract 50. This gives us 29, and then we add the 52, so this gives us 29 plus 52 is 31, 81, and is that correct? So seed 79 goes to soil 81. Yes, okay, it is. I think it is correct. And I think that's it. We can just try this out and see if we get what we want. Yeah, let's run with this, and we got 35 actually, which is what we want for the sample. So what happens if we run this with the actual inputs? And we got an overflow. Okay, so where do we get the, in this? Is this correct? Panic with, attempt to add with overflow, but I think the line cannot be correct because we are, oh yes, because we are adding the length to the source start, and the, yeah, I guess these numbers are, well, everything is quite big. Like, look at this, this is almost 4 billion. Yeah, this is a good example, I think. This is a 3.8 billion number, and then we are going to add the length, which is, well, it's not quite big, this one, right? Unless I, yeah. So I think that this should still be. We can maybe print here. I want to see, but I'm pretty sure that the solution that I will go to is just change every 32-bit number to 64 and, you know, get rid of overflows. But I want to see where this is failing, like with which numbers. So adding plus and this will be self source start and self length. And I don't know if this will be too much. Yeah. Okay, we are adding 3.5 billion plus, yes, 700 million. That seems to go over the maximum for 32-bit numbers. So that is fine. There is a simple thing to do here, which is to just change all of this. Whoops, I triggered a global search. I meant local search. We're going to change this to U64. Please use whole numbers, I think, whole words, and yeah, let's go with that. And if we run again, well, we got a number, an answer, and it didn't bother with this printing. So it's not so many conversions actually, but we got a final answer. Let's try this out. And it is the correct answer. Nice. So we can go to part 2. And this number, how many digits does it have? So okay, it's 1 billion and something. Fine. And if we run now, we don't have this noisy output. Great, so part 2 is a bit shorter, luckily. Let's drink a sip of mate before we go into this. So part 1 was not that complicated if we just follow through and delegated the correct things, I think. We can probably move a little bit of the code around, but yeah, let's read about part 2 and then we can refactor. Everyone will starve if you only plant such a small number of seeds. Great, it starts great. Rereading the almanac, it looks like the seeds line actually describes ranges of seed numbers. So, okay. The values on the initial seeds line come in pairs. Within each pair, the first value is the start of the range, and the second value is the length of the range. Okay. So in the first line of the example above, the line describes 2 ranges of seed numbers to be planted in the garden. The first range starts with the number 79. I just had a like Freudian slip there. 79 and contains 14 values, so 79, 80, up to 92. The second range starts with a seed number 55 and contains 13 values. Now, rather than considering 4 seed numbers, you need to consider a total of 27 seed numbers. In the above example, the lowest location number can be obtained from seed 82. So let's remember this. In the above example, the lowest location number can be obtained with seed number 82. Okay, so 82 is not any of these seeds, but yes, if you consider this range, like it would be within this range of seeds, which corresponds to soil 84, fertilizer 84, water 84, light, blah, 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 and location 46. That is the lowest location? Ah, yeah, okay, because we don't have the seed 13, like, that's not correct. Every seed is higher than 55, actually, in part 2. Okay, consider all the initial seed numbers listed in the ranges on the first line of the almanac. What is the lowest number that corresponds to any of the initial seed numbers? All right. So now things got a bit more complicated because we have huge ranges. Look at these numbers. This is what, like 400 million Then we have 20 million and so on. So I am tempted to sort of brute force this thing and just try it out and run it in release mode and see how fast Rust can go and not think about a very clever solution. So try to, get the ranges. In the sample, I guess it was like, what? How many? 27 or something? Yeah, 27 seed numbers. Like, actually try out all those 27 instead of the 4 that we got on part 1. That will be a breeze for the sample. But then for the actual input, it will be millions and millions of seeds to try. But it's not so many calculations that we need to do for every seed, and computers are pretty fast, so maybe that is actually acceptable to do. Otherwise, I think we would need to do something much more clever. Yeah, much more clever, which would be to, for each initial range, see how it would split. For each range of seeds, see how they fall into each of these ranges on this seed to soil map, and so split each range into like sub ranges that would map to soil numbers, and then map those. Instead of mapping numbers to numbers, we'll be mapping ranges to ranges, and oh boy, that will be because like one range could map to multiple ranges instead of to one, and then we'll have ranges of soils from the initial seeds. I mean, maybe it's not so complicated, but I want to give a try to the brute force solution and see if it could be run in like less than the heat death of the universe, or I guess less than in a couple of minutes or whatever I have patience to run, and get the answer. Well, try to get the answer. Let's see. But first, let's maybe commit this. If we run this with check all, well, this will fail. I didn't run, so it does pass for the sample that we have, but then we need to update the answers. So sorry, answers. What am I doing? Let's run run all. Yeah, this is what I want to run. And now that we have updated that, we can do check all, and it works. Okay. So we have the new answer, we have, well, the inputs, and the solution, I guess, is all right for part 1. We have this range map, we have these things. Map is single number. Instead of, I'm wondering if instead of returning an option here, this could just do the same logic of how we map the whole the number in the whole range, like on the whole map block thingy, because this thing gives you back the same number if no map matches it. So maybe we could do the same here and just return the same number. But no, actually this is better, I think, because we can early return from this loop. So yeah, let's do it like that. So yeah, this is an acceptable part 1. solution. So let's say add day 5 part 1 solution. Okay. Now for part 2. So we have the input. Parsing the input would be even different in part 2, because we have to interpret the the seeds differently. I guess we can just start with same seeds and interpret them as ranges. Okay. So how are we going to do this? Let's keep this. The parsing is fine. We are going to extract this thing, I guess, into a function. Call it well, not like that. I want this expression actually. Min location parts 1. We get the seeds, we get the maps, sure. And we do this this nested loop here, fine. Yeah, this is fine. And then we can, well, let's call this thing what? Just answer 1. And then we're gonna have, what did I do there? I don't know. Well, this will be answer 2, and we're gonna have the same kind of function, but for part 2. And we're just gonna print this and just copy paste stuff. Now, we are not going to just do this with each seed. We're going to have to interpret each seed as a range. So how are we going to do that? You know what? We could even like reuse the min location part 1 for the brute forcing of part 2, because this just needs the seeds and maps. And we can, yeah, I think we could do that. So for the seeds, I think there's a Windows thing, and isn't there chunks? No, chunk, yeah. I never remember which one is the one I want. Chunk exact, chunk, blah, blah. What does chunks do? Iterator over chunk size elements. Yes, I think it is chunks what I want. Yeah. Oh, and it gives you this, but I think chunks, there's also chunks exact, which I think panics. Okay. Yeah, this is kind of what we want. We want to iterate over pairs of seeds. So with this, can we cannot map. Why not? What's your problem here? Size of values cannot be. Yeah, this. Because we are dereferencing here. Yeah, sure. What I want to do is to take, let's say, the seed pair. We're gonna do something. Well, pair, and we know that it's a pair, but I guess we can say something like filter map or something, because yeah, I would really like to have something that in Rust that does this chunking, but gives us like a compile time array, and I'm pretty sure that itertools has that, and I already have itertools, so I'm going to check that. So Rust chunk iterator array chunks. I think this is what I want, but it's an unstable feature. Yes. So let's search for array chunks itertools instead, and I'm pretty sure that we'll have that. Chunkies. Okay. Mm-hmm. Mm-hmm. The last chunk will be shorter. I don't think this is what I want. Yeah, the thing about this is that this can chunk an iterator instead of just a slice, which is like more general than what Rust offers. But I think yeah, this is kind of what I want. Tuples. Okay, it seems like itertools calls this thing tuples. Yeah, tuples is what I want, exactly. I want tuples of 2. So tuples is this, yeah. Oh, this is existing iterators, it seems. So can I say iter tuples? Okay, iter tuples. Where is this thing defined? I guess itertools. So, but I already have itertools. Why don't you like about this? This method takes 0 arguments? What? Because it's a compile time constant, right? So you say tuples, and then whatever you expect, it will infer them. So that's awesome. You can say tuples, and we are gonna map each tuple. So this is a range, so we can say, well, start and length. And now tuples correctly infers this thing. Awesome. Thank you very much, itertools. So now that we have a start and length, I guess what we can do is we're gonna map all of these with the logic that we have in part 1, I think. So yeah, I think that's what I want to do. So let's say start up to start class length, we are gonna map with seed number, and yeah, sort of call this. This goes through all the maps and blah blah. Yeah, we would be doing like this thing. Maybe what I want is a function that follows. We have this map. Oh yeah, no, it is this map number, right? That's what I want. No, this map for a single map, we want to do the whole chain. So that is, I think this is what I want to extract. So extract this into a function. Yeah, and let's call this map seed to how are we going to call it? Like follow map chain. Map number through all blah blah through all maps. Sorry, naming things is hard. So because we already have a single function that is called map number, and I guess we can say map number chain, I don't know, whatever. And this is what I want. We want to pass here the seed as this, I think. And actually, let's give this thing a name like relating to the like what we actually have. Like this is map seed to location. That's better. We can move this over here probably. You don't like this because well, we can dereference you here. Here I want to say map seed to location also with this seed and these maps. Seed here is fine. Can you... What is this? Sorry, I'm just... It's getting confused. So this is the start of the range, this is the end, but these things are referenced. It doesn't like to be dereferenced, so let's just add dereferencing all over the place and not think. It's important not to think. All of this is expected type youth64 found this mapping thingy. Oh yeah, because this is mapping to and here what I would like from this, well, I could get the minimum out of this, and then we have to do the min or, so let's do a flat map instead. and I think that worked. Seed cannot be moved here, blah blah. No, that's not what I want. Well, I think about that later. Oh yeah, maps here. We are moving things over. That's not a good idea. We don't want to move these maps. Let's take them as... We said that a map is this, so this is actually a a vector of maps. Okay, sure. Actually, again, let's replace this with slices, and yeah, make things happier. Awesome. Map seed to location, so we start with a seed and we do the same thing that we were doing before. That's fine. And now we are mapping on part 2. We are getting all of the seeds in the ranges. This will work, I think, for the sample case. So if we can go around blah blah for the sample, let's see. Well, actually, we still need to fix things. Yeah, here seeds. Again, we should not be passing this as a vector. We should be using slices, of course. And now it should compile. Again, try to run this. 46, was this the correct answer for part 2? Yes, it was. But now the thing is, this will take forever to run for the actual inputs. I'm pretty sure. So yeah, running in debug mode is going to take a long time. I would probably like to see some progress in here to have an idea of, you know, when do we finish with the first range, if ever. But I'm going to kill this and maybe add some printing. So for each, man, this iter tuples is amazing, an amazing method to have. That's awesome. So let's print line here and say processing range of starts and length. So we know something, and we are going to also run this in release mode with the actual input. So processing range, and this range has 400 million seeds to process. That is a lot. That is a freaking lot. Oh, but it finished. Nice. So it's not so much. 400 million with a compiled language. 400 millions of elements. It's a reasonable time to wait for a language that is fast enough. So look at it go. We are in the fifth range. So I don't know. We must be over like here or something. We are almost halfway through. So if we wait a little bit, maybe we can get the answer. So this is 300 million and it's done. And look at it go. So if we didn't make any mistake, maybe we do get the answer today. Awesome, or at least in this session. And if we do get the answer, I will take a break. And if we don't, I will also probably take a break. But this is the nice thing about using a relatively fast language. No, I shouldn't say relatively, like a blazingly fast language, as they say with Rust. Like it compares to something efficient, and you know, you can do things like this, working with abstract iterators that, you know, take tuples and things and, you know, instead pretty high level concepts, but in the end you compile to pretty efficient machine code and do brute forcing things that, I don't know, I think with at least with Ruby or Python or languages that I'm used to, if you do this kind of thing, you in the language itself, it will be infinite amount of time to run. Not infinite, but I mean very, very long, and you have to use things like NumPy and things like that that are done in C and not in Python. But okay, 37 million and something for part 2. Is this correct? And yes, it is. Okay. That's really nice. Brute force wins. And look at the advent calendar now. We have the island with this little island where the gardener is working. That's awesome. And we did get the answer after some time. I don't know if it took like a minute or two, but it did finish. So that's great. And we sort of reused the logic that we had on part 1 for part 2, so it's not too horrible, this code. Like, we are reusing most of the things that we already have, so that's pretty good. I will remove this thing. Unfortunately, I didn't time this. I should have run this thing with time command. I'm probably going to do that off screen and amend the commit message. But for now, let's just say add brute force solution for day 5, part 2. And that's it. I'm pretty pleased to have a brute force solution that actually worked. I'm still don't understand this kind of thing. So yeah, since it's taking, like with this taking a reference, it cannot infer what kind of tuples to generate. And I'm pretty sure if we do into iter this, since it is a slice, here Clippy is actually warning me, you know, into iter for a slice doesn't do anything. Like, you should just use iter by itself. We cannot dereference there. I don't remember if Rust syntax allows us to dereference here. Maybe it does. Okay, so can we get rid of this? Yeah. Okay, I think that is somewhat better, though not by a lot. But yeah, I do prefer that. Let's amend the reduce commit. And okay, we have our solutions, or at least our answers for part 1 and part 2, day 5. I will probably try to do this in a not such a brute force way, because I think, you know, we still have the objective of having a fast execution time of less than 1 second for all the puzzles, and this definitely took more than 1 second. And I'm pretty sure that there is a clever way of doing this, but I'm glad to have found the answer using brute force. So I think that's going to be it for this session. And if you have reached this part of the video, thank you very much for watching, and see you next time. Oh, before I always forget, but let's do a little banner here. Maybe we can do it in the Visual VS Code console to have a little bit of the code. And yeah, let's do a toilet with Advent of Code 223, day 5, and this was I don't know, seeds and fertilizers thing. I'll pass it to lolcat and see how it looks. It's a bit too big. That's what she said. Maybe do it in the other console. If here we do toilets, let's open a new console and maybe have the history preserved. So there's fertilizers. Why don't you like that? Oh, because yeah. Okay. Clear the screen. Let's do this. Look at that amazing colors. We can put this maybe to the side. Can we toggle? I don't know if we can toggle like wrapping or something, but yeah, I think this is a bit messy, but can be a good enough thumbnail for today's video. So again, thanks for watching and see you next time. Goodbye.